Hi, we are team number 3. We are Diego, Paco, and Carlo, and we're gonna solve a problem related to kinematics and calculus.
So to get the position function, we have the equation.
So now we have to derivate this formula, and we have that the equation to do this is this one. So the only thing we have to do here is substitute the values that were given in equation.
And this is the result. This is the derivative.
So here what we want to solve for is the velocity of the tennis ball after 3 seconds. So we got that the formula for velocity is velocity 0 plus gravity times time. So we substitute the values that we already have, and we got as the result of velocity minus 36 feet per second.
So when the ball has passed 3 seconds, it has a velocity of minus 36.
Now we want to find the maximum height of the ball. So we have that the formula to do this is this one. Velocity squared minus initial velocity squared over 2 times gravity plus our initial height. So we substitute the values, and you can see that here is 0 because we don't have a final velocity. And then as a result, we got 656.25 feet, and this is the total height. So in our problem, there was a building that weighed 600 feet, and the maximum point the ball reached was this.
Well, first, to solve the problem, we read it, and then we wrote the position function, which gave us y minus initial height equals initial velocity at the y-axis times time minus 1/2 of the gravity times time squared. Then we use the limit definition of the derivative to apply the derivative to the function, which was f of x equals, when the limit is at height in 0, then f of x plus h minus f of x all divided by h. Then we can solve the problem, and we got f of x equals 60 minus 32x. Then we obtain as a velocity at 3 seconds, which gave us velocity minus 36 feet over the seconds. Then we solved for the maximum height and got y equals 656.25 feet. At the end, we calculated the time when the ball is at 600 feet by replacing y of t of time in the position function, and we got time is equal 15 over 4, which gave us 3.75 seconds. And then we finish.
We conclude, as a team, that the relation between the vectors, velocity, and acceleration are in accordance to each other. Without one of them, we could not have what we call the real world. Each object that has any kind of movement, it's affected mainly by these two vectors, and we don't really notice. It is very interesting how all of these variables are affected between them and can be demonstrated in real life and in real problems.